Hello everyone, welcome back to another video. In this video we will be seeing what are data types in Java. Data types are nothing but containers which are used for storing data. Now let's forget about Java for a few minutes. In our day-to-day life, we have different types of containers which are used for different items or different things. For example, if you want to store salt or sugar, we have jars like this. For storing water, we have water bottles present like this. If you want to store more water for water filters, we have water jars available like this. For household activity, if you want to store water, we have water tankers available. For storing oil, we have containers like this, and for storing cutlery, we have something like this. So the point is we have different types of containers available for storing different items. Similarly, in Java, we have data types which are used for storing different types of data. Now when we think about data can consist of numbers or letters. For storing numbers we have certain data types in Java, and for storing letters or characters we have different data type in Java. Now let's see what are those different data types available in Java. So yeah, we can see for numbers there are 6 different types of data types available, or 6 different containers available. Similarly, for storing letters, we have one container or data type available, and one data type is used for storing true-false values. Now you must be thinking, why do we need 6 different data types for storing numbers? When we think about numbers can consist of decimal values, decimal numbers, or non-decimal numbers. For storing non-decimal numbers, we have 4 different data types like byte, short, int, long. And for storing decimal numbers, we have 2 different data types, that is float and double. Now you might have a question like, why do we have 4 different data types for non-decimal number, and why do we have 2 different data types for decimal number? Why not use one for non-decimal and one for decimal? To explain that, let us consider an example. Suppose you want to store someone's age. In the history of mankind, the person who lived the longest is around 122 years and few months. So if I want to store someone's age, I will go for byte data type, because the range of byte data type is -128 to 127. So you can store values up to 127. Now I want to store number of students present in school. In that case, I can go for next data type, which has a little bit of range which is higher than 127. So it can accommodate numbers up to 32,767. Now suppose you have a use case where you want to store number bigger than 32,767 or lesser than -32,768. In that case, you can go for int data type, which has a range from this number to this number. And if you have a use case where you want to store numbers bigger than this or smaller than this, then you can go for long data type. Okay. Now someone can come and ask like, what if I want to store age value inside int data type? Can we store that? Yeah, of course you can store that. But let's see an example. Let's go back to the previous slide. Suppose you have 1 liter of water, and you can store that 1 liter of water inside this water bottle, and you can store that 1 liter of water inside this water tank as well. But what will happen if you store that 1 liter of water inside this water tank? The capacity of this water tank is 1000 liter, but you are storing just 1 liter of water. You are wasting 999 liters of water space. Similarly, if we are storing that age value inside this int data type, we are wasting a lot of memory inside our system. So suppose when you download any image or video into a mobile phone, that image or video will occupy certain space. Similarly, when we use data type, it will occupy some memory or space inside JVM. So we have to choose the data type according to the use case. Talking about space is represented by bits, number of bits. So 1 bit is represented by this square, and bit is the capacity of information that can be stored inside memory. So 1 bit is represented by this square, and it can store values like 1 or 0. So here we can see number of bits. So byte uses 8 bits For short, 16 bits are there. For int, 32 bits is allocated, and for long, 64 bits is allocated. So we can see byte uses a less bit, so less information can be stored inside byte compared to int, which uses 32 bit. So the greater the number of bit, the more information can be stored inside it. Now range is calculated based on bits. It is not some random number which is given here. It is calculated based on the number of bits. So that we will be seeing in our next slide. Now we have seen why do we need 4 different data types for non-decimal numbers. Similarly, for decimal numbers, we have 2 different data types. For float, we have range from this to this number, and for double we have range which is larger than float from this number to this number. The difference is if you are okay with precision up to 7 decimal digit, you can go with float. But if you want precision, more precision up to 15-16 decimal digit, then you can go for double in that case. Now the next data type is char, which is used for storing characters. So again, it is having space allocated up to 16 bits, and it has a range from 0 to 65,535. So char, basically you can hold A to Z, capital A to Z, some symbols. It is used for storing those letters or characters. And the next data type is boolean, which is used for storing true false values. So we have seen all the 8 data types available. These data types are called primitive data types. Now in English, primitive means in the simplest form. So these data types are the simplest form of data types which are available in Java, and it is provided, like it is inbuilt in Java. It is provided by Java by default, and you cannot create your custom primitive data type. So these 8 are the only data types which are available and provided by Java, and they are called primitive data type. So one more thing I forgot to mention is default value. What is default value? Suppose you are using byte data type and you are not assigning any value to it, then the default value it will hold is 0. Similarly, for short it will hold 0. Int will also hold 0. Long will hold 0L. What is this L? It represent long, but we will see what does it mean. Why L is written over here. Similarly, 0.0F and 0.0D. So these are the default values it will hold. For letter, the default is /U40. This represents null. And for a boolean, the default value is false. So if you are not assigning any custom value to it, the default value which these data type will hold is these values. Now let's move on to non-primitive data type. What is non-primitive data type? This non-primitive data type we will be seeing once we study what are classes and object. But in short, non-primitive data type are custom data type. So as a developer, you will be writing your custom classes for storing data. So those classes are nothing but non-primitive data types. Also, Java provides some inbuilt non-primitive data types like string, which we will be seeing in our upcoming videos. Also, one more thing I forgot to mention. The data types which are having range from negative to positive, minus to plus. They are also called signed data type. So it's just a fancy term. Signed means if it is having minus to plus values. So these 6 data types are also called signed data type because they are having range from negative number to positive number. Now let's move on to next slide. So here I have shown how this range is calculated. For example, if we consider byte data type, it has 8 bits. Number of bits available or allocated is 8, and it has a range from -128 to 127. So as I said in my previous slide, that 1 bit is represented by 1 square box. So since we have 8 bits, we have created 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Now for calculating min range, the leftmost bit is for signed bit. So whether it is a negative number or positive number, for that we have the leftmost bit. So in case of negative, it is represented by 1. If it is a positive number, we will represent it by 0. So since we are calculating min range, we will keep it 1 because it's the negative 128. And for positive 127, we will have 0. So the leftmost bit is for representing whether it is negative or positive. In case of negative, we will have 1. In case of positive, we will have 0. And the rest 7 bits are used for representing values. Since we are calculating min range, we want the minimum value. So in 0 and 1, the minimum value is 0. So we will populate 0 in rest of the 7 boxes. Similarly, for max range, the maximum value in 0 and 1 is 1. So we will populate 1 in all the 7 boxes. Now we have to calculate the range. What is the range for this min and max range? So for calculating, we have to start from the rightmost bit. We have to take the value and multiply it by 2 raised to 0. Why 2 raised to 0? 0 is taken because rightmost bit starts from 0 and it increases 1, 2, 3, 4, 5, 6, 7. So we have to start from the rightmost bit. We have to take the value, multiply it by 2 raised to 0. Why we are using 2? Because it's binary number system and it has base 2. It can hold only 0 or 1. So that's why we are using 2. Then you have to add it. Take the next value 0, multiply it by 2 raised to 1. Similarly, we have to do it for the rest of the bit. Till 1, take the value, multiply it by 2 raised to 7. Now when we add this, we will get 128, number 128. Now since the signed bit is 1, which represent negative, it will be negative 128. Similarly, for calculating max range, we have to take the value and multiply it by 2 raised to 0. And we have to do this till the most significant bit or left signed bit. And again we have to add and we will get 127. Since it is 0, it will be positive number. Now we have seen how this range for data type is calculated. Similarly, if you want, you can calculate for other data types as well. It is not necessary to know how this is calculated since no one is going to ask, but if you know it, it's better. The only thing you should know, the types of data types available in Java and number of bits it takes and the default values. These 3 things will be useful. Other than that, you don't have to mug up what is the range for each data type. Nobody is going to ask you that. So this was all regarding data types. We will be seeing how to use this data type once we study variables in our next video. I hope you enjoyed the video. Thank you for watching. See you.